let me introduce a fantastic company from my hometown, Gothenburg, PowerCell, and Mr. Johan Burgren, business manager at PowerCell Group. He will talk about fuel cell installations ongoing in the marine industry. Take it from here, Johan.
Thank you for having us at PowerCell at this event. It's the first time for me that I present here. I see there's a mixed audience, so I will try to be as clear and understandable as possible. So Johan Burgren is my name. I'm business manager for the marine segment at PowerCell in Gothenburg, and we also have other segments. And so I will describe a bit what we're working with more in general from PowerCell Group perspective, and then I will talk more specifically about the marine fuel cells and what's happening in the market as we speak. So PowerCell in the world, very shortly, we are at head office and operations out of Gothenburg, and we're starting up subsidiaries all over the world. We started in China a few years back, where there were subsidies for fuel cell vehicles. So we are in the fuel cell business, right? We are in Germany since many years with the automotive industry, which we have worked closely, also together with Bosch, where we have an agreement on licensing agreement on stack technology. In Norway, we are just starting up, and we are looking at other areas as well. We are basically selling to roughly 50 countries all over the world at the moment. Our strategic partners, you can see a few names in the right to the hand corner. Bosch is a very strategic partner of ours. I mentioned licensing. We have together with them Bosch a fuel cell stack development program that's been going on roughly 4 years now. So our technology is validated together with them, and Bosch is investing in production capacity and validation of our technology. So that means that we have an indirect network of development capacity at PowerCell that goes way beyond roughly the 150 employees that we have in Gothenburg. So we have at Bosch another roughly 100 people that is looking at our technology and validating it. We have other partners here. Siemens Energy is one of our marine partners for integration in the marine industry, and Hitachi Energy basically working on our stationary solutions. We are also listed on Nasdaq since a few years back, and we have a lot of nice shareholders. A few of them are majority owners, whereas Bosch has a corner position in PowerCell since many years. So this is our operations out of Gothenburg. We have testing, we have R&D and production. Right now we are industrializing quite heavily. We are expanding our business, so we have a capacity that is rapidly building up. So we'll be meeting the demands of the market, or the fuel cell market, in different segments. We have our own priority stack technology, also membrane technologies. We're actually developing our own electrolyte and our own cell, which is very, very important. We are not leaving this to the Chinese or any other entity, any other sort of continent to develop our core technology. That is what we do ourselves. We also, as I mentioned, we're validating that technology together with partners as Bosch, for instance. So the hydrogen comes into play in many areas, right? So we've touched upon the aviation industry, which is obviously something that it's quite a challenging industry to decarbonize. There are so many sectors that you can look at. I will talk a little bit more about ports in the next coming slide, how ports can play a role in this energy transition. It's actually an energy transition because then hydrogen becomes an energy carrier, or derivatives of hydrogen, like methanol, ammonia, e-methanol, biomethanol, all types of future fuels. You you have a sort of a place for the hydrogen atom. So ports can play a very vital role in this. I mean, once upon a time, oil spread, I think it was from the US continent, wider to Australia and through the trade routes as it was replacing steam engines. And we came into the use of fossil fuels in maritime industry. And if you look at a port, it has, of course, a very natural position where it is a bunker spot for these vessels, but also it meets other sectors where you have logistics of trucks coming in and out of port, charging or filling hydrogen. You have utilities, you have, of course, the vehicles in the harbor itself, the port handling equipment, as they are called, ship-to-shore cranes, transport equipment, etc., etc. But naturally, the energy needs that and the challenges to really fuel a marine vessel of a reasonable size, like a deep sea shipping application, is of course a huge challenge, and it provides a huge challenge to a grid. So either you can do shore charging, or you actually have to have an energy carrier as the hydrogen molecule or some other kind of fuel that is hydrogen based, that you can apply on board and bunker on board the vessels, and then you can use fuel cells or combinations of fuel cells and traditional engines to use those fuels. So there you have a natural offset. And while we're looking at marine at PowerCell, we're looking at other segments as well. We started our journey in the off-road to the right, together with Bosch. Before Bosch came along, we actually worked in the clusters with BMW, Daimler, Ford, German Ford, Volkswagen. They were part of our sort of tech line setup, that we actually set up the requirements for a fuel cell stack. So that's the stack, it's sort of base technology of the fuel cell. That's where the magic happens in a fuel cell system. That's where the energy is converted from the hydrogen to water and electricity. These stacks is then used in different applications. So we're looking at marine, we're looking at stationary, we're looking at off-road equipment. Those are the major segments. We're also looking at aviation. Aviation is actually the largest segment in terms of sales this year at PowerCell. We have been flying with our fuel cell systems for about 2 years now. So this technology is applicable in many different contexts, and it's scalable up and down and very modular. So we see that as a huge benefit going forward. A little bit like the battery industry, where you can modularly sort of scale up and scale down the power requirements. Just to mention a bit and park our position with Bosch. As I said, they have hundreds of people on this. They have a very determined way to go to market. So they handle the on-road segment as far as now, with a specific licensing agreement. And this actually sort of provides a secure platform for our technology, and we can rely on that our systemization around the stack and the applications in different segments can rely on a proven base technology. So just the discography a bit, the history of our stack development. We started out with a 30 kilowatt stack to the left, the so-called V stack, a few years back. It was introduced, I believe, in 2012 to the market, something like that, 2014 probably. The early iterations, and then we formed what we call developed this P stack. It was formerly called S3 stack. This stack is capable of 100 kilowatts per stack, which is revolutionary in the market when it was introduced a few years back. Then in the next coming years, we will develop stacks that are much more powerful, up to perhaps a megawatt or 300 kilowatts stack. and that is predominantly driven by the aviation industry that has a huge interest in scaling up power needs. If you're going to run a 20-seater or 40-seater, you need power plants of in megawatt scale, and you also need a lot of hydrogen storage or hydrogen derivative storage in order to provide the energy for those flights. When it comes to stacks, you apply them into systems. So you systemize around the stack. You run the stack with hydrogen, and you have to control the air going in. So it's air mixed with hydrogen in the electrolyte of the cell, and it creates energy in terms of DC voltage and current. So that is what we get out. And so we started out quite moderately with 5 kilowatt systems to the left in the picture, moving over to the V-Stack platform, 30 kilowatts, moving over to 100 kilowatt systems, and then now we have a marine unit, the PS200, in the market. So these are products that are mature and industrialized and are being adopted in the market as we speak. Talking about adaptation and application, so a few projects that we are involved in from PowerCell side in the marine sector. This is by far the largest fuel cell ever built on the face of the earth. So 3 megawatts of marine fuel cell, fully classified, means that it's safe, inherently safe to install on board a commercial vessel, and it's approved by Lloyd's Register. The shipyard is a secret still. I cannot mention, but the boat will be in the water, fully commissioned, roughly end of 2023, beginning of 2024, and then this provides for a power of roughly 3 megawatts, and then we will have another. It's going to be a hybrid system on board with diesels and batteries. So it's going to be a hybrid power plant on board, and the owner can select if he wants to run fully sort of emission free. This one is pure hydrogen. So we have here a cryogenic storage of roughly 2 tons of liquid hydrogen. Liquid hydrogen, for you that don't know, is cryogenic, and its temperature is roughly 20 Kelvin, which is close to the absolute zero. It sounds very cold, and it is very cold. Hydrogen is a small molecule, so it's easier to sort of cool down. But nevertheless, it's cool, and it has to stay cool until you want the fuel to be used. So that provides for a challenge, of course. But the tank system is also fully classified by Lloyd's Register, obviously. The next project we're involved in for the maritime space is together with Maritime Partners, who is financing this Hydrogen One push tug, which is going to run up and down the rivers in the inland waterways of US. So this is the first attempt to build a vessel that is methanol fueled. Methanol is going to be reformed to hydrogen and then used in the fuel cell. We have a few other partners here. E1 Marine is the reformer technology that will be applied in the project. ABB is doing the integration, ABB Marine and Ports, I mean. Then you have Elliott Bay Design Group, which is the naval architect. And we all work together in a collaboration and good spirit to get this vessel in the water in a few years from now. And it's moving ahead, and the regulatory part of this is of course very important, as the previous vessel with the 3 megawatts. It's ABS is involved for the safety assessment, and I believe also the US Coast Guard is heavily involved in what regulations should be applied. So 1.6 megawatts of fuel cells together with reformer, and this is methanol based. So I think you all heard, as some of you heard, maybe that Maersk is charging ahead now with methanol fueled container ships, and obviously this is something that spills over to other applications, and perhaps methanol in some segments is the best option, at least for deep sea shipping and those that needs longer autonomy. This is going to be in the water by end of 2023, so pretty much in line with this, with the commissioning of the 3 megawatt system as well, the previous page. Then we have Amogy. Amogy is working with a ammonia cracker technology. They have huge investors behind them, they're good financing. So they are seeing ammonia as a hydrogen carrier. They're going to crack out the hydrogen out of the ammonia, using it in the fuel cell. So basically the same principle as with the methanol, but a little bit of a different story, because we have to do a little bit of adaptation on the fuel cell in order for it to work with the ammonia mixed gas. So ammonia is a bit poisonous to the fuel cell, so we have to redesign a bit the fuel cell to work. This is going to be more of a demo. It's gonna travel the Hudson River. I don't know exactly the timeline. I think it is in 2024-ish. We're going to sail into New York with this tug. Amogy is actually based out of Brooklyn, so it's pretty central and awkward place actually to develop ship technology. Nevertheless, at PowerCell, we have good testing capabilities. So to the left, you see a fuel cell system testing ongoing. We can match this fuel cell. We need to stabilize it and provide power to a switchboard on board, which means that we can also have, we need to have capability to actually verify that test string, and that we can do. So that is in the making for several of these projects that we are running right now. And we can do, they're not only functional development, but we can also do commissioning together with class societies so that they see that this is safe and reliable to install on board. What we typically do in different segments is that we run studies. There's a lot of studies in the market right now. At PowerCell, we try to filter out the ones that we think is going to be something that's actually going to be built. That's the challenge for a start. So we help helping the naval architect in the maritime industry to really build the best concept and work with the integrator, and then perhaps press the button and start building the system. So a system could look like something like this picture. You have a hydrogen storage to the left. Simply, you provide the hydrogen to the fuel cells. The fuel cells have a cooling loop. It needs to be cooled from the ship side. You have a controller that controls the whole sort of set of fuel cells. Fuel cells also are combined through a switchboard with a battery storage. So we peak shave a bit the power need, and the fuel cell are being sort of in parallel operation with the battery system. So actually what happens when the captain pulls the lever is that the power management system just tells this switchboard what it needs, and we provide the power either from the fuel cell or the battery or combination of both. So this is a seamless operation from that point of view, and very efficient. So basically this slide is a bit from just how do you come about service. So if you look at those marine units, we have basically they are completely modularized. So in the blue bar here below, you have a complete sort of power plant of fuel cells on board, and we have these modules could be easily swapped out. So it's designed for sort of easy maintenance and uptime assurance, and we believe it's very important for the maritime client to be quickly up and operating after a breakdown, or if there is a planned schedule we can easily swap out these systems, and he'll be get going again. For some applications, this is actually a little bit of a paradigm shift to the maritime industry. They normally go to dry dock every 5 years, and then you go for these big overhauls of these big engines, 2-stroke or 4-stroke engines. This is a completely different setup where you actually have smaller modules of 200 kilowatts. You just swap them out, you get easily into operation again, and you don't have to go to dry dock. So in terms of cost of operation and sort of de-risking the client in the market, this is what we anticipate. So that was basically it from my side, and please post any questions in the chat, and I can take them on the common questions and answers later on. Thank you.